Hi, I'm Bianca and Dolog.
Hi, I'm Anthony Erilla.
Hi, I'm Jazmine Trivino.
Hi, I'm Gladys Maranan, and we are Kitties!
Activity 1. Printing text in the serial monitor. In this activity, a message, "Hello students," will appear to the serial monitor every second. Activity 2. Showing temperature readings. In this activity, program reads data from a temperature sensor and displays the temperature in degrees Celsius. Activity 3. Checking if the button is pressed. In this activity, the program shows a message when you press a button connected to the Arduino. During this activity, our group faced difficulty in our button. Activity 4. Serial monitor as remote control. In this activity, when we type in 1, the LED will turn on, and when we type in 0, the LED will turn off. Activity 5. Light sensor logging. In this activity, program reads values from a light sensor and displays how bright or dark the area is.
Activity 1. Distance Measurement Display. This video shows how we use distance sensor and display the results. And when the sensor didn't work properly, we fix it by adjusting the wirings. Activity 2. Distance Measurement Display. In this video, we measure distance using an ultrasonic sensor and show the result on the LCD. Activity 3. Obstacle Detector. In this video, we use the ultrasonic sensor to detect the obstacle and light up an LED when something gets close. And even though we had trouble with inaccurate distance readings at first, we fixed it by adjusting the sensor position and checking the wirings. Activity 4. Parking Assistance System. In this video, we show a parking assistance system that uses an ultrasonic sensor, and when something gets close, the LEDs and buzzer warn. We had some issues with the distance at first, but we fixed it by adjusting the sensor and code.
Activity 1. Black and white detector. In this activity, we use IR sensor to detect black and white surfaces. Challenges we face: unstable readings from light interfaces. Solution we meet: adjust the distance and reduce light from accurate detection. Activity 2. Proximity Triggered Siren. In this activity, IR sensor activates a buzzer and LED when something gets close. Challenges we face: false alarm for reflection. Solutions: calibrates the sensor for steady and reliable to respond. Activity 3. Count the buzzers. In this activity, IR sensor counts objects passing by and show on LCD. Challenges we face during this activity: miscounts for past movements. Solution we need: added short delay for accurate counting.
Button-controlled DC motor using MOSFET. To control a small DC motor with a push button and an Arduino, connect the button so that when pressed, the motor runs. When released, it stops. The wiring is easy, and we face no issues during the setup. DC motor speed control using potentiometer and MOSFET. Instead of simply turning the motor, to control the motor speed, use a potentiometer to set on or off. Always double-check your wiring before connecting to the ports to prevent mistakes.
Activity 1. Motor Power Control. In this activity, we use an Arduino and L293D H-Bridge to control a DC motor that turns on and off every second. The motor didn't work until we connected all the grounds.
Motor speed control. Instead of simply switching the motor on and off, we can control its speed using pulse width modulation. To prevent issues with battery connections, it's important to use high-quality wires. Motor direction control. By utilizing two Arduino pins, you can control the motor's direction clockwise or counterclockwise and observe how an H-bridge alters polarity. Always double-check your wiring before connecting to the ports to avoid mistake.
Bridge Activity 4 is push button motion direction control. One button will make the motor rotate forward, while pressing the other button will make it rotate reverse. If no button is pressed, the motor will stop. During this activity, I struggle to connect the wires properly, but I'm still able to do this activity.
Activity 5. Motor direction and speed control using push button and potential meter. In this activity, the motor direction and speed were controlled using push button and potential meter. Challenges: unstable motor movements. Solution: fixed wirings in a dead zone.
In our robotics journey, it has always been tough for us. The pressure to finish all the tasks, proper teamwork, and time management to do all the activities. The first time we got into robotics class, I knew it was hard, to the point that we couldn't even finish the task. Other wirings and components aren't working as well, which give us hardships to comply with all the activities. But as the time goes by, the robotics class has become more exciting and fun. Not only that, we also learn several components, and it gives us happiness whenever the wiring is working. This moment changed our perspective in robotics class. It became more enjoyable and even taught us to work in a team on each task. It also boosts our critical thinking when it comes to technology and fills us with knowledge. Robotics journey might be hard, but it is fun over time.
We learn to be patient and to properly arrange the position of the components or materials we use, especially when using ultrasonic sensor. We also apply critical thinking to solve the software problem. Overall, robotics is not easy, but it feels easier when your team works together and patience is practiced.
A components that we would like to try is the soil moisture sensor. It measures the volumetric water content in soil, usually by measuring electrical resistance or capacity between its poles. It's essential for creating a smart irrigation system or an automated gardening robot. We would also like to try the MQ2 gas sensor. It detects the presence of various flammable gases like LPG, propane, etc., and smoke by measuring the change in resistance of its sensing material. This adds a crucial safety monitoring feature. A robot equipped with this can be a mobile gas leak detector, autonomously patrolling an area to sense dangerous air quality changes and trigger an alarm.
The components we would like to try next is the rain sensor. It detects rainfall and can trigger automatic systems like irrigation or weather alerts. This sensor helps in creating smart projects that responds to changing weather conditions. We want also to try LDR sensor. It's measures the intensity of light and helps control lighting system or monitor sunlight for plants. This sensor is perfect for energy saving and smart lighting application.